Welcome to this video on key value stores. Here we're going to explore simple NoSQL data stores, focusing on Redis and DynamoDB. Key value stores are a fundamental concept in modern database design, offering simplicity and speed. Let's dive in and see what they're all about. So, what exactly are key value stores? They are a simple yet powerful NoSQL database model that stores data as a collection of key value pairs. Each key uniquely identifies a value. These stores are optimized for fast lookups and writes. They use a schema-less data structure, providing great flexibility. And the values can be simple, such as strings or numbers, or complex objects like JSON documents. Here's an example of basic key value operations. To set a key value pair, you use the command set, followed by the key and the value. To retrieve a value, use the command get, followed by the key. And to delete a key value pair, use the command del, followed by the key. Let's explore the core characteristics of key value stores. First, they offer high performance, optimized for O1 lookups and writes, making them extremely fast for simple operations. This makes them ideal for caching, session management, and real-time applications. Secondly, they provide scalability and are easily horizontally scalable across multiple nodes. Their simple data model allows for efficient data partitioning and distribution across clusters. Next, they exhibit flexibility with a schema-less design that allows storing any type of data without a predefined structure. Values can be strings, numbers, JSON objects, or even binary data. Lastly, they feature a simple application programming interface or API. This API offers minimal, straightforward operations such as get, set, and delete. Reduced complexity compared to relational databases, with no joins or complex queries. Now let's take a look at Redis. Redis is an in-memory data structure store that can be used as a database, cache, message broker, and streaming engine. It offers in-memory storage with optional persistence. It supports multiple data structures like strings, lists, sets, and sorted sets. Redis also features built-in expiration and eviction policies, making it useful for caching. Finally, it provides publish or subscribe messaging and stream capabilities. Here are some examples of commands that are used to interact with the data in Redis. For string operations, you can set a key with a value using the set command and retrieve it using the get command. For hash operations, you can set multiple fields within a key using the hset command and retrieve all the fields using the total command. To perform list operations, you can add elements to a list using the push command and retrieve a range of elements using the range command. Now let's explore the different data structures that Redis offers. First, we have strings. Strings in Redis are binary safe and can store up to 512 megabytes of data. You can use them to store text, serialized objects, or any kind of binary data. Example, set key value, get key. Next, lists are linked lists of string values, sorted by insertion order. They are very efficient for adding and removing elements at both the head and tail of the list. Example, push mylist item 1, range mylist 0 -1. Hashes in Redis are maps between string fields and string values. They are perfect for representing objects with multiple attributes. Example, HSE username John, HD username. Sets are unordered collections of unique strings. They support operations like union, intersection, and difference. Example, sad my set, member 1, smembers my set. Sorted sets are similar to sets, but each member has an associated score for ordering. They're ideal for implementing leaderboards and priority queues. Example, ZADD scores 100, user 1, zrange scores 0 -1. Finally, streams are append-only collections of map-like entries. They are designed for event sourcing and messaging systems with consumer groups. Example, XADD my stream asterisk field value, zret streams my stream 0. Let's shift our focus to DynamoDB. DynamoDB is a fully managed, serverless key value and document database that delivers single-digit millisecond performance at any scale. It's a fully managed Amazon Web Services service with automatic scaling. DynamoDB boasts consistent single-digit millisecond latency, even at large scales. Security, backup, and restore functionalities are built in, ensuring data safety. It provides flexible pricing options, with both pay-per-request and provisioned capacity modes available. Here's an example using the DynamoDB JavaScript Software Development Kit, or SDK. This code snippet shows how to put an item into a DynamoDB table. It defines the table name and the item to be inserted, including attributes like user ID, name, and email. The dynamo.putItem function is then called with these parameters. On successfully putting an item, a message is logged. Let's delve into the key concepts of DynamoDB. First, primary keys are essential. DynamoDB supports two types of primary keys: a simple primary key, which consists of only a partition key, and a composite primary key, which includes both a partition key and a sort key. The partition key is used to distribute the data across partitions, while the sort key is used to sort the data within a partition. Here is an example. User ID user123, which is the partition key, and timestamp 16345678990, which is the sort key. Next, tables and items are also vital. Tables, like in other databases, are containers for items. Items are a group of attributes identified by a primary key, similar to rows in a relational database. Here's an example. Inside the users table, an item may contain a user ID, which is user123, and a name, which is John Doe. Secondary indexes provide alternative ways to access data beyond the primary key. There are two types: global secondary indexes, or GSIs, and local secondary indexes, or LSIs. A GSI has a different partition and sort keys than the base table, while an LSI has the same partition key but a different sort key. Here's an example that indexes the email attribute. Finally, capacity modes offer different billing options for processing reads and writes. With provisioned capacity, you specify read and write capacity units in advance, whereas on-demand capacity provides pay-per-request pricing and autoscales based on your application's needs. Let's explore some common use cases for key-value stores. First, caching stores frequently access data in memory to reduce database load and improve application response times. In Redis, this involves caching database queries, API responses, and computed results. Next is session management, which stores user session data with fast access and optional expiration for web applications and services. With Redis, this consists of storing session tokens, user preferences, and shopping cart data. Another use case is real-time analytics, which tracks metrics, counters, and statistics with high throughput and low latency for dashboards and reports. Redis is used for counting page views, tracking active users, and storing leaderboards. Messaging implements publish or subscribe patterns, message queues, and event streaming for decoupled, scalable architectures. This can be implemented in Redis in use cases like chat applications, notification systems, and task queues. Finally, mobile and Internet of Things, or IoT applications, store device data, user profiles, and configuration settings with high availability and low latency. DynamoDB is typically used here for mobile app backends, device registries, and sensor data storage. And finally, rate limiting implements API rate limiting, throttling, and request counting to protect services from overuse. Redis can be used for API gateway rate limiting and login attempt throttling. Let's compare Redis and DynamoDB. Redis can be self-hosted or managed, while DynamoDB is fully managed by Amazon Web Services. Redis stores data in memory with persistence options, whereas DynamoDB uses solid-state drive or SSD-based storage. Redis requires manual or cluster configuration for scaling, but DynamoDB offers automatic, serverless scaling. Redis provides rich data structures such as strings, lists, sets, and others, while DynamoDB has limited data structure support like documents and sets. Redis offers sub-millisecond latency, whereas DynamoDB provides single-digit millisecond latency. Redis is typically priced based on resource usage, while DynamoDB offers pay-per-request and provisioned capacity pricing models. So, key-value stores excel at simple high-performance data access patterns with minimal schema requirements. Choose Redis for in-memory performance, rich data structures, and versatile use cases. Choose DynamoDB for fully managed, serverless scaling with predictable performance. Consider data access patterns, consistency requirements, and operational overhead when selecting a key-value store. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.